Class, what's the first step? Do we have an equation? What's your favorite Greek letter? Alpha. Alright, what's the next thing? Let's switch them. Taking the inverse is a better word, thank you. Before we do that, what's another way of saying arc cosine? So now that I switch them, I'm going to have cosine alpha equals radical 2 over 2. Raise your hand if you have that so far. Okay, with your trig paper plate now. Now, notice the order I go in. If this is a positive or a negative, I always like to think of the positives first, right? So put your finger where cosine is positive. You should have 2 locations. You should have these 2 locations. All the trig functions and cosine is positive. Put your finger where cosine is radical 2. You should be recognizing it's the first order pair. Radical 2's are the 45s. You should have pi over 4 and 7 pi over 4. Raise your hand if you got that. Okay, now, because we took the inverse, I need the restrictions for cosine. What is the restricted domain for cosine?
0 to...
So if you don't have your chart, 0 to pi. Okay, here's the hard part. Fractions. I need a common denominator. What's our lowest common denominator? 4. Look. Make it a fraction by 1. These have 4s. So I'm going to multiply by 4. So I get 4 times 0, which is 0 pi in some ways, over 4, and then this one's going to become 4 pi over 4. So this is kind of like my cheesy number line. Yes or no, is 1 pi over 4 in here? Yeah, it's right there. So this is kind of like a visual to help you. Class, is 7 pi over 4 in here? Okay, pay attention now. I've looked at step number 3, restricting the domain. Now I'm going to look at coterminal angles. 8 pi over 4 is a full rotation because that reduces to 2 pi. So if I subtract 8 pi over 4, I get negative pi over 4. Is negative pi over 4 in here? It would be somewhere over here. If I add 8 pi over 4 to this, that would be too big. That would be 15 pi over 4. So my final answer is alpha equals pi over 4. Double check your answer that it fits within your restricted domain. Alright, on Friday we focused on just sine and cosine. Now we're going to open it up to other trig functions. I'm going to set it equal to my favorite Greek letter, beta. We're going to change arctangent to be what? Inverse of tangent of 0 equals beta. We're going to switch these. Just like a light switch, don't forget to, if you use it, turn it off. So I have the tangent of beta equals 0. Okay. Now, 0 is neither positive nor negative. Yes? This pi implies that it's the quadrantal angles. Quadrantal angles on my unit circle is the yellows, the x and the y axis. Remember, tangent is which 2 letters, class? Y over x. So essentially what we're doing is we're taking the second order pair and dividing by the first. Class, what's 0 divided by 1? 0. Does that make us happy here? Yes. Yes? So that would be 0 pi, or 0. Would this work? 1 divided by 0?
No.
1 divided by 0 would be undefined. How about here?
Yes.
0 divided by negative 1?
0.
Yes. Negative 1 divided by 0?
No.
No. I'm going to look at my RTD for tangent. Because we're taking inverse of tangent, that means it better be between negative pi over 2 and pi over 2.
Wouldn't it count to pi over 2? Or is it just 0?
Yeah, this one you can either use 0 or 2 pi. And the coterminal angles will help you. Okay, now I need some equivalent fractions. I have 0 pi over 2, and this one will become what? 2 pi over 2. Yes or no?
Yes.
Yes or no?
No.
No. Remember, that's like a 1. So think of a number line. -1. This is +1. So 2 would be out here. Okay, if I subtract a full rotation from this. Now pay attention. That's 4 pi over 2. 2 minus 4 is?
Negative.
-2. Too much. If I add 4 pi over 2, 6. Does that meet it? No. So your answer is going to be just 0. At 0 radians. Or you can also say 0 degrees. Now, what's more difficult about tangent is because you can't see it right away. You have to do y divided by x. And these are the two trig inverse problems we just did. Alright, Shiv. B or D? Alright, let's go over B. What do you do first? What letter? Why? Use a Greek letter. Okay, what do you do next? Tell me how to write.
Cosine y equals -1.
Correct. Shiv, where is cosine -1?
Just pi.
Correct. First order pair. Remember, it goes cosine, sine. If you forget, alphabetical. X, Y, cosine, sine. Cosine's -1 at pi. Thank you, Shiv. And Luis, what is the restricted domain for cosine? What does the brackets mean? It stops. Okay. Ha, that's a good question. You're at the door, the bell rings. Do I let you in or not? The bracket means you include the solution at pi. Bracket means don't let them in. So this one says y equals pi. Class, does that fit in here?
Yes.
Yes, it does. Raise your hand if you got that. Good job, good job. Leslie? Let's do this next one. What do you do first? Okay, what do I set it equal to? Why? Now what? Tell me what to write. So this one says negative, but listen to my question, Leslie. Where is tangent positive? We have this acronym that helps us, and it tells us where they're positive. Correct? Tangent is positive here, and? Second quadrant means sine and its reciprocal cosecant are positive. Everything else is negative, so tangent would be negative here. So I'm trying to figure out the positives. So that would be A and T. That means I know that tangent is negative in these two quadrants. Do you guys see how I did that?
Yeah.
So if I'm looking here now, I'm looking for something to be -1. Now if you think back to graphing tangent and cotangent, you know that it's only 1 and -1 where? At the 45s, or pi over 4. To make it more simple, what color is that?
Pink.
The pink. Why is it the pink? Now, here's my trick, and then I'll explain why. If I do y over x, this would be a positive radical 2 over a negative radical 2. Something over itself is equal to -1. 3 pi over 4 can be your answer. And what's the other location?
7 pi.
7 pi over 4. Now, let me explain why I cover up. The 2. So here you should have positive, negative, right? So this is in a y and this is an x. So if I do negative radical 2 divided by, so this is y divided by x. I'm explaining to you why my trick works. It's not a trick, it's just class, how do you divide fractions? You take the reciprocal, but that turns into what? Multiplication. And then what happens there? Your 2's cancel. Do you see that? Now this also cancels. Remember, canceling in this case equals what number? 1. So your answer is going to be a -1. Okay, that's why the trick works. Why I'm covering out with my fingers the denominators. I'm only looking at the numerator. So I can just do something like, that should be a negative, there it is. Negative radical 2 divided by radical 2 is -1. Okay, now I need the restrictions for tangent. Ryan. Okay, tell me more. Parentheses or bracket?
Bracket.
You're looking at your chart?
Oh, parentheses.
Parentheses. What do I write there?
Negative pi over 2 and pi over 2.
Okay, so I have -1. You can't see that. -1, that's my -1. -1 pi over 2 and positive 1 pi over 2. I need a common denominator. Class, what do I do for a common denominator here?
Multiply by 2.
Yeah, we're going to multiply this one by 2 over 2. So it gives us -2 pi over 4 and 2 pi over 4. Class, yes or no? Does this fit?
No.
Yes or no? No. Yes or no?
No.
That'd be outside as well, right? Okay. All done?
No.
What's the fourth thing?
Coterminal.
Okay, so coterminal in this case would be what number? 8 pi over 4, says the future dentist. So 8 pi over 4, I'm either adding or subtracting. It's a full rotation. Okay, let's think about this. 3 plus 8, does it fit in here?
No.
No. 3 minus 8,
No.
that's -5, way over here. 7 plus 8,
The T is way
too big. 7 minus 8,
That's negative
that equals -pi over 4. So what did we do in this case? What will work? Pay attention. 7 minus 8 gives me -pi over 4. Class, is -pi over 4 in our restricted domain? Yes. -pi over 4 is the answer. Now, a lot of students will actually get here. They'll say, Mr. Ng, if I subtract 8 pi over 4, then 7 pi over 4 will work. But remember, is 7, positive 7, within these bounds? No, it's only it's a coterminal angle, which is -pi over 4. This fits in here. Here's two examples of using the inverse trig function and using our restricted domains.